something. Any guesses?
Stops increasing and starts decreasing.
If it stops going up and it starts to go down, it's going to hit a what?
Increase.
Maximum. Thank you, Jake. Stops increasing and starts decreasing. And so, in this case, we only have one relative maximum, but it'd be the value, so a relative maximum of what? 228. That's the value. At, and I need where it is, so I need to say at x equals 2.35. That's it. Right? I need what the value is and where it's located. And it's easy to identify because that's where the function stops increasing and starts decreasing. What are your questions, concerns, and comments?
Would it be wrong for just put the point?
Yes. Not wrong, but not full. Not complete understanding. Because when we talk about a relative maximum, it is a relative maximum value, and so I want you to tell me what the value is and separate that from the where it's located. Now, if you justify it well and tell me why that's the answer, I would probably say 5P or 5D for that. So 5 out of 6 is still really strong understanding. So wrong, not quite complete in its understanding, no. So what about a relative minimum? Any guesses of what the relative min would be?
Where it stops and
Well, I just mean it for this problem. We'll get into the definition in a second. Negative 68.2. Don't forget at x equals 7.65.
Come on,
And so a minimum value for that section of the graph, and again, I was gonna say, hopefully that means we can study well, learn a lot, where the function stops blank and starts blank. So when we have a relative minimum, what is it stopping doing? Decreasing and starts to increase. That's the only way you get a minimum. What? I really should move this up, but I want you to notice here's some notes in bold on the black for number 7. But a lot of us, I think, forgot about the context of this problem. Remember, we originally had a rectangular sheet of paper, right? And then what did we do to that rectangular sheet of paper to fold it up and get a volume, a rectangular prism? We had to cut the corners, right? We had to cut out those corners with a square. So we got to remember, what is the lowest value that we could have actually cut out? Say it again, Preston. 0, in a way. Now, can you really cut out 0? No. But that's why for here, what we would say is that the domain, and I will say this, you could use a bracket or parenthesis, but technically I would probably use a parenthesis because you can't really cut 0 out. But could you cut out like a 0.1? Yes. So it's everything getting up to 0. It's not realistic, but you could do all the way up until 0. What was the maximum? So remember, this was an 18 by 12 sheet of paper. What was the maximum that we could actually cut out? 6. Look at the graph between 0 and 6. That's all of these points. Because we can't cut out less than 0, we couldn't cut out more than 6, and that should make sense, because what was the volume before and after those points? Negative. Can you get a negative volume? Heck no, right? So that context, right? We have this whole function for everything possible in relation, but when we consider the context, that context limited the domain and range. Context limited the domain and range. It had to fit inside the real world. So, smallest length of corner cut and largest length of corner cut. And then once we identify that domain, that limited domain, we could identify the range a little bit more easily. What was the lowest range value? Remember, range, is that my x or my y? The y. What's the lowest y value? So we're thinking vertically now. Lowest. What is it? 0. Right? Now, can you actually have a volume of 0? No, it's not actually a rectangular prism, so bracket or parenthesis, really. You can't actually have it, so it would be a parenthesis. You use a parenthesis when you cannot actually have that value. Now, it depends on the way you justify it. That's what I would consider the most accurate response, but you justify it well, I'll take it. So what would be the maximum volume that we see there possible? 228.
Oh, yeah.
Bracket or a parenthesis on that one? Does it actually have a value of 228 for the volume?
Yes.
So you would definitely want a bracket in that case. Okay? Say again?
Confusing me with brackets and parentheses.
Say it one more time.
You're confusing me with brackets and parentheses.
A bracket means that that function actually has that value.
Okay.
A parenthesis means that the function does not have that actual value. So the whole thing is, if I talk about volume, and I'm talking about a rectangular prism, can a prism have 0 volume? No. That's why it has a parentheses. Cannot actually have that value. It's a, what it really is that you're approaching that number, but you never actually get to that number. Is the most mathematical way to really explain it. All right, last one. I assume you'll want to discuss number 11.
Yeah.
Yeah.
Sure.
Sure. Looking at number 11, I'm sorry I'm rushing a little bit, I just want to make sure we get time for the due diligence here. Please note that it asks us to dilate g of x. So there's g of x. If I'm dilating, what mathematical operation is that? Multiplication. And we're dilating it by x. That's the function you should have been graphing. So I would have rewritten that as x times what? There we go. There it is. X times x plus 1 times 2x minus 4. Notice, originally, g of x was what type of function? Parabola, a quadratic function. The shape is a parabola. We dilated by x, and now what type of function do we have? Cubic. This is what I mean by the transformation by a non-constant value. It completely changes the function, right? We just went from a quadratic to now a cubic. We want to recognize that transforming by non-constant values, that's what that number 1 question was all about. It completely changes the nature of that function. It doesn't matter what function you started with. You transform by a non-constant, it changes the function and its nature. Now, y'all need to remember this next part. What is, or how do we go about words? What's the first thing we need to do?
Identify the zeros.
Don't ever forget that. Do not ever forget
I
that.
was looking worried.
ID those zeros. And we literally talked about this in number 10, and this is why Miss Courtney and I decided to add question number 10 in there. How do we identify those zeros?
Set equals zero.
Set what? Don't stop using it. Set what?
The X.
Nope, that's the issue.
The Y.
The Y, which is why we end up setting the factors. Really what it is at its core is 0 is equal to x times x plus 1 times 2x minus 4. But because of that, I can set each factor equal to 0. Does anyone remember what property tells me that? Zero product property, right? Really what it is where you got there eventually, Liam, of the y value is 0, but because of the zero product property, I can set each factor equal to 0. And then I gotta solve. By the way, what am I gonna do here? Multiplicative inverse, so times, thank you. Remember, the priority really is creating the identity. What is the multiplicative identity? 1, but I do like you to use that reciprocal, it'll help you in a lot of cases. So 1x is equal to 2. Okay? So we have all my zeros. And so some students in first block were like, well, Mr. Kenny, after that I get a little lost. I'm okay finding the zeros. And that's cool. I understand. But what I want to remind you of is this. Can you go ahead and graph those zeros on the coordinate system? You can graph them. Notice there's one of the zeros right there already on the graph. There's one of the other zeros right there on the graph, and then I have x equals 0. That can help you visualize where to start and stop with your x values. If that is my lowest 0, what's the x value that we might want to start with? Negative 3. I like 2 to the left. And I mean, I do want a little justification about why you chose those x values, but there it is. Now, at the end, what do I want? And this is something y'all really should be thinking about. The dilated, which is x times g of x. Hey, I already have x, right? What do I still need? G of x, that's it. Now, you can split it up into 2 different columns if you want, that's fine. Personally, I'm just going to do g of x equals, I'm going to write the equation, x plus 1 times 2x minus 4. And I'm just going to get g of x right then and there. And so, what's a way that I could, if x is negative 3, how could I figure out what g of negative 3 is? So first of all, don't ever forget I could just substitute it in. And you can use the calculator to speed up this process. This is known as evaluating. This is what Ms. Courtney was getting y'all to do over the last couple of days, and to think about it, substituting that x value in to get my y value out.
Teachers, please pardon the interruption. Just want to let you know that Ms. Heaton will be in the lobby during lunch today selling entrance tickets for the field day. So if you'd like to purchase one of those, please stop by the table in the lobby and see Ms. Heaton. Thank you.
So we get a 20, right? And then I can substitute the negative 2 in, and when you do that, you get 8. When you substitute a negative 1 in. Now here's what I do want you to notice. If you can, you have a graph. Here's negative 1, comma what?
0.
You don't have to substitute that in. What's the output? 0, right? When the x is 0, what's the output? Negative 4. Remember, I'm trying to look at g of x. And so you can use your graph and go from there. And then remember, it's just x times g of x. Negative 60, negative 16, 0, 0, negative 4, 0, 24, and 80. We just graph the points that we can, and don't sweat the small stuff. I already have my zeros there. I'm going to graph the other points that I still need. Which really is just 1, negative 4. That's the only point. Now I do still want to pay attention to the other points to know what's happening. Up to this 0, is it decreasing or is it increasing? It was already negative, so it's got to be, remember, if it's already negative, it's increasing up to that 0. To get from a negative to a 0, it's increasing. So I'm just going to approximate. Now you got to be careful. What has to happen between the zeros? It's got to stop increasing and start to decrease. I don't know where exactly, but I know it's got to stop increasing and start to decrease. It's got to go into the positives. Now I have 1 point down here. And then I've got to come back up to get to that 0. And I don't have any more zeros, so it's going to continue. Not perfect, but that's pretty darn close. That's what we've been doing. Graphing the points that we can and approximating throughout from there. Do we have a better understanding? Quick thumbs up if we understand that question a little bit better overall. Yes, better, better. Are you smiling because someone in your group? Yeah. Yeah. Yeah, negative 3. Oh, no. Wait, you talking about that 20? Yeah, negative. By the way, I do want to point out, just to make your life easy, it's a quadratic. I didn't actually plug any of these in. I just noticed the symmetry. Symmetry is beautiful. So, we'll have a little bit more of this tomorrow, or on Monday. Again, don't forget I won't be here Monday. Miss Courtney will be leading the rest of lesson 4, getting as far as we can. If you need to take a picture, here is the reflection and praxis assignment that you should be looking at. The reflections and practice assignments you should be looking at. Or don't take any pictures. I don't care if you want. Yeah. You're taking it tomorrow? Yeah, you can. Yeah, you can come back. Yeah, I'll pull your yes. Yeah, if you ever want to borrow a calculator for the ACT, I'll try your name up on the board and make sure you clarify. Those should be charged right there. So you go and grab them. Like unplug it. Take off the hat because you don't need that. But if it has a green light next to it, it's charged.
They don't go to there.
Huh?
They don't go to there. So you bit money.
Yeah, you did alright.
Bit money.
Show up on time.
I know.
Alright.
You said take the what off?
This little hat right here.
Oh.
It's called a hat. Honestly, do you really want to know? No, that's pretty good. Yeah.
I know my car's on too, so I'm straight. You know, I'll just chill.
Test prep? Super score? I only took the test. Now I've taken a lot more since then to do tutoring. Like I have a lot of practice tests I've done. But yeah, before I took it the summer after my sophomore year. And I made a 34 and I've never looked back.
Okay, bye-bye.
And Kenny.
I had a phenomenal schooling and education.
Come on, man.
So, like, y'all see the product of a lot of hard work over a lot of years, but I had phenomenal teachers that pushed me way beyond what I ever thought I could do, which is why I pushed y'all. But it's because of that I found way more success than I ever thought possible. Yeah, but if you ever want some, I have probably 15 to 20 old ACTs that ACT themselves have released as PDFs. I can email them to you. And I also do not private, but I do small group tutoring for the ACT. So, you're more than intelligent enough to make 20s times. To be fair, I think you're even more intelligent than that. You just haven't had the education that you need to score. I don't know if that makes sense. But you're super intelligent. You can score a goal. No. There's no might. You should take it again. You should definitely take it again. Because I assume you're looking to play in college, right? So like, because here's the thing. Because here's the thing, you score much higher than that, then the scholarships end up lining up evenly, right? So like, you're way better than the minimum, right? You need to shoot for those mid to high 20s, because you take high academics with phenomenal skill, they're gonna want you, you're capable of a lot. Just let me know what you want. I'll be here to help you. Oh, Rich, you got my black?
JT, big boy.
How's it going?
You know what? I'm not gonna lie to you, Mr. King. It's going better.
Good.
Got covered with my favorite show,
What show?
Psycho Tech.
Dude, I'm caught up. I'm so ready for this weekend.
Dude!
So ready. Did you know that they're not